All right, so this next section, we're going to continue on with spontaneity. We're going to be talking about acidified solutions on your table. Those are the ones that have H plus, and we're going to also talk about water. It occurs a few times on your table. You got to watch out for that. Water is always a special case. Remember, with spontaneous reactions, they're always looking for the Z pattern, right? Higher on the left, lower on the right of your standard reduction and potential half cell table. For non-spontaneous reactions, you're going to have the S pattern, higher on the right, lower on the left. So look for those patterns. Take out your standard reduction potentials table if you haven't done that already. All right, so acidified solution. So this is any reaction on that table that includes H plus is an acidified or acid solution. All right, so if we look at our acidified permanganate solution, so our electron potential right near the top, fourth from the top on your table, and we can see that it's H plus in the solution. All right, so that's our acidified permanganate solution. All right, so just finding that. So on our next screen, so I what I wanted you to do is find the acidified iodate solution. All right, so you can see that it's positive 1.20. So the iodate, IO3 minus, and the H plus means it's acidified iodate. Acidified dichromate, that's at positive 1.23. All right, so notice it on your table. CR2O72 minus, and we see the H plus, right? Anytime there's an H plus, that means it's acidified. And then we got acidified manganese 4 oxide, and that's at plus 1.22. All right, so just find these guys on your table. Don't be surprised if they come up. You should know the name from it, your dichromite, iodate, manganese 4 oxide. You should know the name and know how to find them on the table. All right, so other ones, so we got nitric acid, sulfurous acid, and phosphoric acid. So these acids in their ionized form on the table. All right, so find these as well. HNO3 found in 2 places. So you often see this one coming up in questions because it's a little more tricky and it's in 2 places. And so depends on what it's bound with, you're going to have different products being formed. So you see one at 0.96, you have the nitric acid, and then you're going to form NO and H2O. And then you have at 0.80, you're going to be forming N2O4 and water. H2SO3, this is found at 0.17 volts, and you can see that and find it on your table as well. All right, so water, it's a special case. At the top of the table is written ionic concentrations are at 1 molar solution. All right, so notice at the top, so everything's at 1 molar except for 2 things. So this includes all the H plus, and then water. So we see neutral water. These are in the shaded lines. It's kind of hard to see on your data tables, but in your book, they're in shaded lines, but just notice it on your table. You got 0.82 volts and negative 0.41 volts. All right. And you can see that shows 10 to the minus 7. If we remember back to our acid and base section, 10 to the minus 7, that is just a natural dissociation for water at room temperature. So that's 7.0 pH. So that's just the concentration of your H plus or your OH minus. So you see that 10 to the negative 7, and you know that it is neutral water. All right. So neutral water on the right side, 0.82 as an reducing agent, and neutral water as an oxidizing agent on the left at negative 0.41. Okay, so find both of those, right? You're going to be talking water. You have to compare it with both of them. So if you can see below at negative 0.83 in solution. So we can see, so look at your table, negative 0.83. So it doesn't have 10 to the minus 7. So this is a 1 molar concentration of your OH minus, right? So be prepared for that. So each OH minus is 1.1 molar. And you can also find acidic water near the top at 1.23. And you can see the H plus, it will have a 1 molar solution as well. So be aware of these ones. So it's acidic, not neutral for these ones. So water, again, just to clarify, comes on your table 4 times. 2 of them are neutral. 1 is acidic water and 1's basic water. All right, so looking on your table, all right, you're going to use these. You're going to answer these questions. What I would suggest: pause it now, do the questions, and then I'll come back and explain it to you again. If it's going to react, if it's going to oxidize, it's going to reduce. Look for that Z pattern: higher on the left, lower on the right. If it doesn't have that Z pattern, then it's not going to react. All right, simple as that. We'll talk about F and G, those are tricky ones, and we'll talk about those in just a moment. Okay, neutral water oxidize your Fe, yes. Water's going to oxidize iron, below and on the right, making that Z pattern. Again, with their chromium, below and on the right, making that Z pattern, and sodium as well. Will neutral water reduce Au3 plus? All right, so look at your table. Yes, it's gonna reduce Au3 plus. We see Au3 plus is above and on the left, and our water is below and on the right at 0.82. Ag plus, no, it's not gonna do Ag plus. We can see Ag plus below and on the left to the water. So Ag plus is at 0.80, and water's just above it at 0.82. All right, so it's above and on the right, so it's not going to reduce. Acidified permanganate solution. So that's your MnO4 minus, H plus, that's at 1.51 on the table. Will acidified permanganate solution oxidize O2 minus, right? So oxidize, you're going for oxidizing the SO4 2 minus, you're going from the right to the left. But you look at that permanganate, it's below and on the left to the SO4 2 minus. All right, so no, that's not going to work. Br minus. All right, look at that one. Yes, it's below and on the right. And your zinc, yes, below and on the right. Nitric acid react with silver. Yes, nitric acid is going to react with silver. You have the Z pattern. Au, no, it's an S pattern. Non-spontaneous. I minus, yes. And Cl minus, no, you're going to have that S pattern. All right, so always look at the S or the Z. Z, yes. S, no. Will nitric acid react with Fe2 plus? Yes, making the Z pattern. All right, so this one's a little bit more tricky. These two, nitric acid react with Hg to form N2O4. All right, so you look at your table, right, and find your nitric acid, and it's going to be on the table twice. All right, so you got the one at 0.96, and you have another one at 0.80. So what you want is the reaction that's going to happen, and then you see two mercuries as well. So one at 0.85 and another one at 0.80. The reaction that's going to happen is the one that's furthest apart. So it's a spontaneous reaction. So it's the one that's the one that's going to happen. It's the one that's furthest apart. So it's going to be that one at 0.96 and the nitric acid at 0.96 and the mercury at 0.80. So that's the reaction that's going to happen. So no, it's not going to form the products N2O4. All right. And it will form the product NO. All right, so that's a tricky one. You always want to go with the one with the largest potential difference. That's the reaction that's going to happen. So I kind of think of it as water. Water's like you got a waterfall, you're making the Z pattern, it's always going to flow to the lowest spot. So you have the highest difference between them, and that is the reaction that's going to happen. All right, so look for that. You have questions like this from the book. Next one, you're just looking for the Z pattern. Can you safely put a gold ring in acidified dichromate solution? Yes, it has the S pattern, so it's not going to react. What about acidified permanganate solution? No, don't do that. You will dissolve the gold ring. If Cl2 gas is dissolved into water, will it remain Cl2 gas or will some become Cl minus? So what you need to do is look and see if Cl2 is going to make the Z pattern or the S pattern. And you look, it's going to make the Z pattern with the water. So we got Cl2 on the left, 0.136, and water below on the right at 0.82. So yes, some of it's going to be converted to Cl minus. All right, if you have any questions of these, ask them in the chat. Next is finding the products of spontaneous reactions. So again, it's just keep on going with the Z or S pattern. So you have SN4 plus and H2S. So these are our reactants. So you find it SN4 plus, that's at 0.15, all right, on the left. And our H2S is right below it at 0.14, right? So it's making the Z pattern, right? So those are your reactants. Reactants are still reactants on the left. So if we look at it, our SN4 plus, this is going to be 2 electrons. It's going to SN2 plus. SN4 plus 2 electrons goes to SN2 plus. So SN2 plus is going to be one of our products for that. And our other one, the oxidation reaction, H2S is going to go to 2 electrons and 2H plus and an S. All right, so that H plus and the S, the solid sulfur, those are going to be our products as well. So just to go over this, the higher reaction on the table will be the reduction reaction. This is going to be all through the unit. So memorize that in your mind. So you're putting two things together. Whatever's higher on the table will be a reduction reaction. This is the one going forward. The lower reaction will proceed to the left. This will be the oxidation reaction. Higher is the reduction, lower is the oxidation, right? So you have the reactants on both sides, just like at the top, for SN4 plus, H2S, those are reactants. And then our products are going to be SN2 plus, and then S and 2H plus. So you're just going to reverse it. So see how the arrow is going that. So therefore, our products are going to be S2 plus, S and H plus. So don't worry about the coefficients yet. We're going to work on balancing these reactions. A little bit different, but very much the same as balancing other types of reactions that you learned in your chemistry 11 or in junior sciences. So don't worry about those coefficients yet. All right, so let's do some of these questions. Not too difficult. Pause it right now, go through the questions, and then see if your answers match mine. All right, so what are the first one? What is the products of the reaction of acidified hydrogen peroxide, H2O2? So see that way up at the top, 1.78, and Br minus. So higher is a reduction, so H2O2. All right, so look at the other side. That's just going to be our water, right? So water is going to be one of the products, and our Br minus, right? It's the reaction, so it's a spontaneous reaction. So Br minus below and on the right, and its products are going to be bromine liquid, Br2. All right, so those will be our products, H2O and Br2. What are the products of the reaction when neutral water reacts with calcium? All right, so neutral water, it's either going to act as an oxidizer or a reducer, oxidizing agent or reducing agent. So with this one here, calcium, you're looking at the neutral water at negative 0.401 as the reduction reaction. So for that one, you're going to be producing H2 and 2OH minus. And our calcium, look down, we're going to be going Ca2 plus. All right, so those are our products, H2, OH minus. I know OH minus, you could put it on or not put it on. It's going to be 10 to the minus 7, but for all intents and purposes and with balancing later, put it on the reaction. We'll balance everything else later. So those are our products. So just finding the products. Zn. All right, so Zn, right, it's a little bit higher up than our Ca, right? You can see it at 0.76, but it's going to be very similar. It's making that Z pattern with our neutral water at negative 0.41, right? So water products are going to be the same, and then we're going to make Zn2 plus. Then Br2. Br2, a little bit different. So we see that it's going to react spontaneously with the water at 1.23. All right, so we have the reaction here. It's going to make O2, H plus, and our Br minus. Acidified MnO4. All right, so we look at this one, and our products are going to be Mn2 plus, H2O, O2, and H plus. And then fluorine gas right at the top, it's going to make the pattern of O2, H plus, and your F minus. All right, I would do questions from the book, page 199, 11, and 12. If you have any questions, put them in the chat.